Look up at the night sky. On a clear night, far from the neon glow of our cities, you see a dazzling tapestry of light. You see stars, the glowing clouds of nebulae, the soft smear of the Milky Way, and perhaps a few wandering planets. It feels vast. It feels complete. For thousands of years, humans believed that what they saw was the sum total of reality. We thought the universe was made of stuff, atoms, light, and heat. But as our telescopes grew larger and our mathematics more precise, we stumbled upon a terrifying, humbling truth. Everything we have ever seen, every star in every galaxy, every planet, every mountain, every human being, and every single atom in the periodic table is nothing more than a tiny glowing foam on top of a vast, invisible ocean. The stars and galaxies we marvel at make up only 5% of the universe. The other 95% is missing. It is invisible, untouchable, and completely mysterious. It consists of two phantoms that rule our destiny: dark matter and dark energy. Today, we're going to dive into the greatest mystery in the history of science. We're going to explore the dark side of the cosmos. To understand the first part of this mystery, we have to look at how galaxies move. In the 1970s, an astronomer named Vera Rubin noticed something that shouldn't be happening. She was watching how spiral galaxies rotate. According to the laws of physics, the same laws that govern how planets orbit our sun, stars at the very edge of a galaxy should be moving much slower than the stars near the center. It's basic gravity. The further you are from the mass, the weaker the pull. But Rubin saw something impossible. The stars at the outer edges were racing around the galactic center just as fast as the stars in the middle. By all rights, these galaxies should have flown apart. There simply wasn't enough visible stuff to hold them together. It was as if an invisible hand was clutching the galaxy, providing extra gravity to keep everything in place. She had found the first solid evidence for dark matter. Imagine you are watching a merry-go-round in a park. It's spinning at 1,000 miles per hour. You don't see anyone holding onto the horses, yet the horses aren't flying off into the trees. You would have to conclude that there is some invisible rope, some hidden force, keeping them anchored. That is dark matter. It is the cosmic glue. So, what is it? We know what it isn't. It isn't made of atoms. It doesn't emit light, reflect light, or absorb light. It's not dust, it's not gas, and it's not even black holes. If it were, we would see it blocking the light from distant stars. Dark matter is like a ghost. It passes right through you, right through the earth, and right through the sun without leaving a trace. Millions of dark matter particles are likely streaming through your body at this very second, and you feel absolutely nothing. The leading theory is that dark matter is made of WIMPs, weakly interacting massive particles. These are theoretical particles that have mass, so they have gravity, but they don't interact with electromagnetism. This is why we can't see them. We only know they are there because we can see their gravity tugging on the stars. Without dark matter, you wouldn't be here. In the early universe, regular matter was too hot and too spread out to clump together. Dark matter acted as the scaffolding of the universe. It clumped together first, creating massive invisible wells of gravity. Regular matter then fell into these wells, eventually forming the first stars and galaxies. Dark matter is the silent architect of everything we see. It makes up about 27% of the universe. But as strange as dark matter is, it has an even more mysterious cousin. And while dark matter pulls things together, this second force is trying to rip the universe apart. Welcome to the enigma of dark energy. For most of the 20th century, astronomers believed the universe's expansion was slowing down. They thought that after the Big Bang, the mutual gravity of all the stars and galaxies would eventually act like a brake, slowing the outward rush of space. Some even thought the universe would eventually stop and collapse back on itself in a big crunch. Then came 1998. Two independent teams of astronomers were studying distant exploding stars called Type Ia supernova. They were trying to measure how much the expansion was slowing down, but when the data came in, they were shocked. The expansion wasn't slowing down at all, it was speeding up. The universe is accelerating. Imagine throwing an apple into the air. Instead of slowing down and falling back into your hand, the apple shoots upward, faster and faster, until it disappears into the clouds. That would be impossible unless some invisible energy was pushing the apple away. That invisible push is dark energy. It is a property of space itself. And it is the dominant force in the cosmos, making up a staggering 68% of the universe. Einstein actually predicted something like this. He called it the cosmological constant. He originally added it to his equations to keep the universe static, but when he learned the universe was expanding, he called it his biggest blunder. Decades later, it turns out he might have been right for the wrong reasons. Space isn't just empty nothingness. Space is a thing, and according to quantum physics, even empty space is filled with a bubbling energy. As the universe expands, more space is created. And because there is more space, there is more dark energy. This creates a feedback loop. More space leads to more push, which leads to even more space. This brings us to a terrifying realization about the future of our universe. Dark matter and dark energy are in a cosmic tug-of-war. For the first few billion years of the universe, dark matter was winning. It pulled matter together to form the galaxies we love. But about 5 or 6 billion years ago, as the universe grew larger and matter became more spread out, dark energy took the lead. Now, dark energy is the undisputed king of the cosmos, and it is driving the universe toward a very lonely end. If dark energy continues to accelerate the expansion, the big freeze, or the big rip, awaits us. Tens of billions of years from now, the space between galaxy clusters will grow so fast that they will disappear over the cosmic horizon. Our neighbor, Andromeda, will merge with us, but every other galaxy in the sky will vanish. The night sky will go dark. Eventually, the expansion might become so violent that it overcomes gravity within galaxies. Stars will be ripped away from their cores. Then it will overcome the gravity of solar systems. The Earth will be torn away from the Sun. Finally, the expansion will become so powerful that it will overcome the electromagnetic forces holding your atoms together. The fabric of reality itself will be shredded. This is the big rip. Every single thing in existence will be reduced to isolated, lonely particles separated by trillions of miles of expanding nothingness. It is a grim prospect, but it also highlights how precious this current moment is. We live in a brief window of cosmic history where the light from other galaxies can still reach us. We live in a time where we can still see the evidence of our origins. The enigma of dark matter and dark energy is a profound lesson in humility. We once thought we were the center of the universe. Then we thought we were just one planet among many. Then we realized our galaxy was just one of trillions. And now we realize that we aren't even made of the same stuff as the majority of the universe. We are the 5%. We are the light matter, the rare exception in a dark, invisible cosmos. But there is a silver lining. Because we are made of regular matter, the matter that interacts with light, we have the unique ability to observe. Dark matter can't see the stars. Dark energy can't wonder about its own existence. But we can. We are the eyes of the universe. We are the tiny 5% that has spent the last few thousand years trying to map the other 95%. Think about the genius of the human mind. From our tiny rocky home, using nothing but the light hitting our glass lenses and the logic in our brains, we have managed to deduce the existence of things we cannot see or touch. We have weighed the invisible. We have measured the phantom energy of the void. There are still so many questions. Is dark energy a constant, or does it change over time? Could dark matter be a signal that our understanding of gravity is fundamentally wrong? Scientists are currently building massive underground detectors, like the Lux Zeppelin, and launching incredible satellites like the Euclid mission, specifically to hunt these shadows. We are on the verge of a revolution. Just as the discovery of the atom changed everything in the 20th century, the discovery of the nature of dark matter and dark energy will redefine the 21st. We are living in the golden age of discovery. We are the generation that is finally beginning to peel back the dark curtain. We are moving from a universe of light into a universe of truth, no matter how strange or dark that truth might be. As you go about your day, remember the scale of the mystery you are part of. Every step you take, you are wading through a sea of dark matter. Every breath you take, the space around you is being pushed by an energy we don't understand. You are a walking, talking miracle of the 5%, a glowing spark of consciousness in a vast, dark cathedral. The universe is far stranger than we can imagine. It is built on foundations we can't see, and it is heading toward a destiny we are only beginning to grasp. But that is what makes being alive so incredible. We are the explorers. We are the ones who look into the dark and ask, "What are you?" Thank you for joining me on this journey into the invisible. This has been one of the most requested topics on the channel, and for good reason, it is the ultimate puzzle. If this deep dive into the dark side of the cosmos expanded your mind, please hit that like button and subscribe. It really helps the channel grow and allows us to keep making these long-form explorations for you. And I want to hear your thoughts in the comments. Does the idea of the Big Rip scare you, or do you find the mystery of dark matter exciting? Do you think we'll ever truly see these invisible forces, or are some things meant to stay in the dark? Let's get a conversation going below. The universe is 95% mystery, but it's that 5% of light that makes the search worthwhile. Keep looking for the truth, keep supporting science, and above all, keep looking up. I'll see you in the next video as we continue to explore the infinite together. Safe travels, everyone.